क्लियर है? एनी काइंड ऑफ डाउट गाइस? किसी को कोई डाउट है? यस एंड नो? निकाल लोगे डायरेक्शन मैग्नेटिक फील्ड की? नाउ जिस फोर्स के बारे में वी आर टॉकिंग अबाउट, वी आर टॉकिंग अबाउट द फोर्स, मैग्नेटिक फोर्स. सो हाउ टू calculate the value of magnetic force? That particular magnetic force is given by Lorentz. Okay, so it is also termed as Lorentz force, and we will see the expression of this. Force F on a charge q due to magnetic field B is F vector is equals to q, the magnitude of charge, into velocity vector multiplied by the magnetic field vector. So suppose there is a magnetic field like this, and a charge particle q is present here. So this q, if it is moving with a velocity vector v, let's say the magnitude of this magnetic field is v vector. So we will see that F vector, the force vector, the applied force by the magnetic field on this charge is q into v vector cross v vector. Okay. If you open up this expression, it will become qvb sine theta. This is the magnitude, and simply if you open this here, so it will be qvb sine theta into n cap. Okay, where n cap is the unit vector perpendicular to both f vector and b vector. So we will write this thing here: unit vector perpendicular to both f vector, sorry, v vector, which means velocity, and b vector, which means if you will see now, these three, v b and f, the velocity of charge particle, magnetic field, and the force on the charge particle, these three physical quantities are mutually perpendicular to each other. ठीक है? नाउ अगर कोई भी दो प्लेनर हो गए, मतलब वेलोसिटी भी बी के प्लेन में आ गई, या फोर्स बी के प्लेन में आ गया, या फोर्स वेलोसिटी के प्लेन में आ गया, तो इन दोनों में से अगर कोई भी प्लेनर हो गया, so in that case what will happen? The angle between them will become zero. Sine zero will become zero. There is no force. Okay, like in this situation, if you will see, this is the direction of magnetic field, and in the same direction velocity vector is there, so angle will become 0 degree. So we can say that force vector here is zero in this case, because you put the value of sine theta as sine zero. Sine zero is zero, so force vector will become zero. Clear? Now ये सब चीजें आपको पता ही है, which represents what? Now some properties के बारे में we will talk about it. This magnetic force will depends on magnitude of the charge, velocity of the charge particle, and magnetic. This magnetic field is not generated by the charge. This magnetic field is external. ठीक है, तो ये याद रखना है. The magnetic field is external. This magnetic field, this force will become zero if the charge is stationary. अगर चार्ज स्टेशनरी है तो वेलोसिटी विल बिकम जीरो. ठीक है, जब वेलोसिटी जीरो होगी, सो क्यू वी बी, विच मीन्स वी इज जीरो, तो फोर्स विल जीरो. अगर मैग्नेटिक फील्ड जीरो हो गया तब भी फोर्स जीरो होगा. अगर चार्ज का मैग्नीट्यूड जीरो हो गया तब भी फोर्स क्या होगा? जीरो होगा. और वेलोसिटी और मैग्नेटिक फील्ड का एंगल भी अगर जीरो हो गया तब भी फोर्स हमारा क्या हो जाएगा? जीरो हो जाएगा. ठीक है, so zero when the charge particle is stationary, n is zero if the angle between b and b is zero or 180. यानी कि v और b या तो पैरेलल हो या फिर एंटी पैरेलल, ठीक है. either velocity and magnetic field like this, or they are behaving like this. Clear? Now this one. We have seen this previously and I told you the same way we are going to use for the force also. So here if you will see, thumb is representing the direction of force. This is velocity. You have to make like this. Okay. So thumb is representing force. This is representing velocity. And this is representing, this middle finger is representing magnetic. So you can see that these two are also perpendicular to each other. These two are also perpendicular to each other. And these two, this middle finger and this thumb is also perpendicular to each other. Okay. So all three are mutually perpendicular. Clear? And always remember which hand you have to use. So this is right hand. ठीक है. देखो यहाँ पे आप इजीली देख सकते हो. देखो वेलोसिटी और बी वेक्टर सेम डायरेक्शन में हो रहे हैं, तो फोर्स क्या हो जा रहा है, जीरो हो जा रहा है. जैसे जैसे एंगल इनके बीच का कम होता जा रहा है तो साइन की वैल्यू भी कम होती जा रही है, इस वजह से फोर्स क्या हो रहा है, जीरो हो रहा है. ठीक है ना. यहाँ से भी आप देख सकते हो जैसे जैसे एंगल बिटवीन वेलोसिटी एंड मैग्नेटिक फील्ड डिक्रीजेस, मैग्नेटिक मैग्नीट्यूड ऑफ द फोर्स विल डिक्रीज. ठीक है. क्लियर है? यस एंड नो? एनी काइंड ऑफ डाउट गाइस? किसी को भी कोई डाउट है? देखो, नाउ we will talk about the previous concept that we have learned in the electric. So what is the force when a particle or a charge particle is present in the electric field? So it will definitely be q into e. F is equals to q into e. Now what is the force on charge q due to magnetic field? It is q into v vector cross b vector. What is the combined force? So combined force is given by, ये डायरेक्ट लिख दिया, मैं यहाँ पे लिख के बताता हूँ आपको. F vector is given by F electric plus F magnetic. ठीक है. F electric is q into e vector plus F magnetic is q into b vector cross b vector. ठीक है. So F vector will become what? Q हमने कॉमन ले लिया. It will become e vector plus b vector cross b vector. ठीक है ना. किसी को कोई डाउट है? जेएनवी, अमरेली, कशामा, नागाश्री, एनीवन? एनी काइंड ऑफ डाउट? कृष्णा, भारत, शिवमानी, श्रेया इज ऑल्सो हियर, मधुकर. कोई डाउट है भाई? यशवंत? अब एक एक का नाम लेके पूछना पड़ रहा है, बताओ. चलिए नेक्स्ट टॉपिक पे बात करते हैं. मैग्नेटिक फोर्स ऑन अ करंट कैरिंग कंडक्टर. ठीक है. अभी तक हमने बात की, वी हैव टॉक्ड अबाउट कि देयर इज अ मैग्नेटिक फोर्स ड्यू टू द करंट कैरिंग कंडक्टर. जब भी हम किसी वायर में करंट को फ्लो करा रहे हैं तो देयर इज अ जनरेशन ऑफ मैग्नेटिक फील्ड नियर द वायर. वी हैव सीन द expression of what? Expression of magnetic force, which is also called as Lorentz force. ठीक है. On a moving charge particle, how the magnetic field applies a force, and combined force we have seen till now. Now we will deduce an expression for magnetic force on a current carrying conductor. ठीक है. देखो, this is the conductor that we have, cylindrical conductor we have considered. Wire भी आप इसे बोल सकते हो. There is a wire and here is the flow of electron. The length, the observable length that we are taking is this L. तो यहां से इलेक्ट्रॉन एंटर किया और यहाँ पे एग्जिट किया। ए इज फॉर एरिया ऑफ क्रॉस सेक्शन ऑफ दिस सिलेंडर। ठीक है। अब देखो यहाँ पे क्या है, एन इज द फ्री इलेक्ट्रॉन नंबर डेंसिटी ऑफ द वायर विच मींस नंबर ऑफ इलेक्ट्रॉन पर यूनिट वॉल्यूम। एन क्या है, नंबर ऑफ इलेक्ट्रॉन पर यूनिट वॉल्यूम। Q is the charge on one electron. Q क्या है? Q will be the charge on one electron. L is the length of the wire. A is the cross sectional area of the wire. और this is I. ये I है. This is L and this is I. I is the steady current flowing through the wire and VD is the average drift velocity of the electron. Drift velocity के बारे में we have already talked about in the current electricity. ठीक है? Who is going to tell me what is drift velocity? Any one of you? Tell me in the comment box what is a drift velocity. Now, magnetic force on a current carrying conductor. So first of all, we will calculate how many charge particle do we have. क्योंकि जितने चार्ज पार्टिकल होंगे उतना ही उन पर मैग्नेटिक फोर्स लगेगा। ठीक है। सो फर्स्ट ऑफ ऑल वी विल कैलकुलेट हाउ मेनी चार्ज पार्टिकल्स जो भी है। ठीक। सो कितने चार्ज पार्टिकल होंगे, नंबर डेंसिटी कितनी है, एन है, विच मींस number of electron per unit volume. If I just multiply it with the volume, then I get the total number of electrons. So n into length of the cylinder is what? This is L and the area of cross section is A. So the volume will become area into length, L into A. Now total charge what it will become? So total charge will become total electron into charge on each electron. और चार्ज कितना होता है हमने क्यू चार्ज हमने कंसिडर कर लिया। ठीक है। Now, force on electron F is what? Total charge into drift velocity because each electron is moving with the drift velocity. So there is a V. So in the expression of QVB, V will replace by VD. Okay. Q is this NLA into Q. This is the total charge and V is the magnetic field. Okay. Now, so current density को we can say that N into Q into VD. From the previous chapter we can say that J is equals to Ne NQ into VD या आप Q को E भी बोल सकते हैं, इज द इलेक्ट्रॉनिक चार्ज। ठीक है। तो यहाँ पे अब कैलकुलेशन करेंगे फोर्स F की, तो वो क्या बन जाएगा, देखो NQ VD इंटू आई इंटू ए मल्टी दिस इज क्रॉस प्रोडक्ट विद बी वेक्टर। लेट मी डू इट हियर फॉर यू। फोर्स वेक्टर इज व्हाट, Q इंटू बी वेक्टर क्रॉस बी वेक्टर। क्यू टोटल चार्ज कितना कैलकुलेट किया था, एन आई एन एल एन एल ए इंटू क्यू। बी कितना है, बी डी मल्टीप्लाई बी वेक्टर। ठीक है। अब देखो करंट डेंसिटी क्या होती है, जे को मैं क्या लिख सकता हूँ, आई अपॉन ए विच मीन्स टोटल करंट डिवाइडेड बाई एरिया। ठीक है। हमने एक एक्सप्रेशन और पढ़ा था अगर आप लोगों को याद है तो, we have seen an expression this is I is equals to NEAVD और यहीं से we have seen that J is equals to what, NE into VD। ठीक है। अब देखो यहाँ पे N भी है, E का मतलब है Q और VD भी है, तो इस सबको हम क्या लिख सकते हैं, J लिख सकते हैं कि नहीं, J लिख सकते हैं NQ VD। अब देखो मैंने वेक्टर प्रोडक्ट में से एक वेक्टर को बाहर ले लिया। ठीक है। तो मुझे अंदर भी क्या मल्टीप्लाई करना पड़ेगा, एक वेक्टर ही मल्टीप्लाई करना पड़ेगा। अब क्या बचा है मेरे पास, एरिया है और लेंथ। अब ये एरिया तो वेक्टर नहीं है, तो क्या मल्टीप्लाई करना पड़ेगा, लेंथ मल्टीप्लाई करना पड़ेगा। ठीक है। So as you can say, J into A will become यहाँ पे I. So J into A L वेक्टर क्रॉस B वेक्टर. तो फोर्थ मेरे पास क्या आ गया देखो. J को क्या लिख सकता हूँ. I is equals to J into A. So J into A will become what? Current. And this is length vector multiply by B. क्लियर है सभी को. किसी को कोई डाउट है इसमें. एनीवन एनी काइंड ऑफ डाउट इन दिस. ये समझ में आना बहुत जरूरी है. इट इज वेरी इंपॉर्टेंट टू अंडरस्टैंड दिस एक्सप्रेशन. इफ एनीवन हैज एनी काइंड ऑफ डाउट यू कैन आस्क राइट नाउ. एवरीवन. अनिल क्रिस्टियाना जेनवी अमरेली. अच्छा लेट मी ask you one thing. Which chapter is going on in your current syllabus of physics in JNV regular classes? Which chapter is going on right now? And I'm asking this question to everyone. Everyone has to reply. Okay? Because there are different JNVs. So I want to know that which chapter is going on in physics in your regular JNV classes. So start with Bhagat. Answer in the chat box rapidly. Okay, ray optics. Which means you have completed this chapter. Huh? Have you completed this chapter? Okay. I think almost everyone has completed this. I just wanted to know. ठीक है ना, so that I can increase my pace and we will do lot more question solving in this. ठीक है. So magnetic force क्या expression क्या है. F vector is equals to I into L vector cross B vector. अभी ये L vector को कैसे लेना है. What will be the L vector, that will also be decided. And I am going to tell you there is a concept behind it. How to select this. ठीक है. तो यहाँ पे क्या है. F is the magnetic force on the electrons. I is the current flowing in the wire. And L is the length of the wire. B is the external magnetic. ठीक है. Now, ready for the challenge. This is the question for you. Try to solve this question and tell me the answer. What is the answer you are getting? I'm giving you 2 minutes to solve this question. Everyone try to attempt it. A straight wire of mass 200 gram and length 1.5 meter carries a current of 2 ampere. It is suspended in mid-air by uniform horizontal magnetic field. What is the magnitude of the magnetic field? Everyone, 2 minutes you have, and I'll see that which JNV student answer it in the first. देखते हैं who will win. Let me write what is given in the question. Mass of the wire is given. Okay, one has answer. Who has answered भाई? नागश्री has answered. चलिए देखते हैं नागश्री का सही है या नहीं. ओके, थ्री स्टूडेंट हैज आंसर. देखते हैं किसने किसने जवाब दिया अभी. सबसे पहले तो नागश्री नहीं दिया है. जेनवी रायचूर, प्रियंका भगत. ओके. So let's say this is the magnetic field. Cross means this magnetic field is going in into the plane, and this wire is suspended by this, and the length is L. Okay, like this. So there is a weight of the rod mg acting downward, which means if the this wire is suspended in midair by the magnetic field, so the magnetic force is acting upward. This is Fm vector, and Fm is given by what? I into L cross B, which we can simply say that I L B sin theta. Now, if magnetic field is inward, this is a horizontal magnetic field, this one, and magnetic force is this. So theta between length vector and magnetic field, this is the length of the rod, and magnetic field के बीच में एंगल कितना हुआ? 90 डिग्री. थीटा इज 90 डिग्री. So sin theta is equals to 1. Magnetic force on the rod is ILB. अब देखो, एज द रोड इज सस्पेंडेड इन एयर, तो मास किसके, जो वेट फोर्स है वो किसके बैलेंस होगा? मैग्नेटिक फोर्स के. तो यहाँ पे एम जी अपॉन आई एल, सब डेटा आपको गिवन है. व्हेन यू पुट इट यू विल गेट 0.65 डेसिबल. सो प्रियंका एंड जेनवी रायचूर, भगत, नागश्री, जस्ट चेक योर कैलकुलेशन. ठीक है, कॉन्ग्रेचुलेशन गाइस, यू आर एब्सोल्युटली करेक्ट. ठीक है. नाउ one more question if I just give you here. Suppose we have a wire like this. ठीक है, but not like this. The wire is like this. This is the starting point, this is the end point, and the current is flowing like this. So what is the effective length that I have to take to calculate force vector? It is I L vector cross P vector. So if the wire is not straight, then which length we have to take? देखो, length vector you always have to decide in the direction of current. But here, if you will see, the direction of current is like this, and this. But if you will see, the magnetic field is inside or outside. Each and every time, if you consider this as length, this is also perpendicular to the magnetic. If you consider this is also perpendicular. If you consider this is also perpendicular. So always remember that this, if you just join the start point to the end point, start joining the point from where the current enters in the wire, join it with the current from where the current is going outside. So this particular length you have to take as L effective. Okay. Although the expression of force, you can say it is df vector, small force for a small length you can calculate, dl vector cross B vector, and when you take the integration of it, it will become the forces. But in these types of case, this will be the effective length. Now tell me, if this is a semicircular ring, a wire is bent into a semicircular ring, what will be the effective length force on this wire by the magnetic field if the magnetic field is inside? बताओ, only expression of the force. The radius of the ring is r. ठीक है? Radius of the ring is r. Okay. So I have launched a poll. You have to answer in the poll each and every question. Okay. So first of all, finish the poll. Then I'll start solving this question. Okay. देखो, I have told you when there is a arbitrary shape of the wire is given. So only the starting point from where the current enters and the end point from where the current is going getting outward. So these 2 points you have to join. Okay. This particular is the length effective. This is the effective length. So force vector here will become I into L effective is what? 2R into क्रॉस बी वेक्टर. अब देखो 2r वेक्टर इज इन x डायरेक्शन and magnetic field in the z direction, negative z direction. What is the angle between them? 90 degree. So force vector will become I into 2rb 2rb sine 90. So force will become 2ir. Clear? Any kind of doubt? Yes and no? Any kind of doubt, guys? Only half of the student has participated in the poll. Try to make it 100%. Okay. Everyone has to respond here. So in the next class, we will do the Biot-Savart law and see what is the magnetic field due to a current carrying wire. Now we have seen a magnetic force due to a current carrying wire. Okay? That is applied on a current carrying wire in the presence of external magnetic field. In the next day, we will see what is the magnetic field developed by the electric current wire. ठीक है? Because ओरेस्टेड ने जब वो एक्सपेरिमेंट किया था वहां पे मैग्नेटिक फील्ड जो नीडल थी वो डिफ्लेक्ट हो गई थी ना, which means there is something magnetic field which is generated by the electric current. So we will see the expression of that by with the help of Biot Savart. Okay. If anyone has any kind of doubt, you can ask right now. Okay. Otherwise, the lecture is being over. Thank you so much for being attentive and being responsive.